Hello everyone, this is Tagni Popi from Institute of Digital Anti-Aging Healthcare in India University, South Korea. Today's my presentation topic is overview of potentials of multiple instance learning in cancer diagnosis, applications, challenges, and future directions. These are the contents of my presentation. First of all, we will discuss about MIL, multi-instance learning, fundamentals of multiple instance learning, applications of multiple instance learning in cancer diagnosis. Then we will discuss about the advantages of MIL in cancer diagnosis. After that, the challenges associated with MIL will be discussed, and also future directions and emerging trends will be discussed. And lastly, we will conclude our presentation. So, despite advances in cancer research, the mortality rate of cancer patients is still alarming, rendering it a severe threat to human life. Accurate and timely cancer diagnosis is crucial in determining appropriate treatment strategies and improving patient survival rates. Traditional diagnostic methods such as histopathological analysis, imaging techniques, and biomarker assessments rely on subjective interpretations and may have limitations in terms of sensitivity, specificity, and reproducibility. In recent years, advanced machine learning techniques have emerged as powerful tools to address challenges and enhance cancer diagnosis. While using computer-aided diagnosis and machine learning methods, cancer datasets often exhibit characteristics such as class imbalance, noisy labels, and complex interactions between features, further complicating accurate diagnosis. Overcoming these challenges enables a growing need for advanced machine learning techniques in cancer diagnosis. By leveraging computational power and advanced algorithms, machine learning approaches can improve the sensitivity and specificity of cancer diagnosis, enhance risk stratification, and aid in treatment decision making. Multiple instance learning is a machine learning paradigm that has gained attention for its applicability in many areas, including image classification, drug activity prediction, text classification, and object recognition in computer vision, among others. MIL is a weakly supervised learning approach that deals with specific types of problems and is helpful in cases where the supervised methods are unsuitable because of the lack of causal labels or annotations in the dataset. In MIL training, data is organized into bakes with instances. MIL is a machine learning paradigm that gained attention for its applicability in many areas. So as we discussed that there are multiple implementation of MIL. So we can use it for drug activity prediction and also for object recognition and many areas of application of MIL. So in MIL, training data is organized into bakes with instances. This is a little bit different from the traditional deep learning models or methods in which we focuses on the bakes. We have different bakes, and in bakes we have instances. And the bake is called positive bake if it contains one positive class, and negative bake means all the tissues or all the instances in that bake is negative. So here is you can see these figures showing the positive bake, negative bake examples. And for example, you can see on the left side, it contains one positive and all the others are negative. So this is positive bake. And in the center, you can see it is negative bake because all the instances are negative. And at the right side of the bake, you can see it contains both positive and negative instances. So it will also be called as positive bake. So fundamental of multiple instance learning. Multiple instance learning is gaining interest from industry and academia because it fits a variety of problems and allows us to leverage weakly labeled data. Multiple instance learning is a form of weakly supervised learning where training instances are arranged in sets called bakes and a label is provided for entire bake. In MIL, training data is organized into bakes with instances, as we discussed before. So uh, a whole slide image, histopathological image, can be represented as a bake of instances and its pages as instances using MIL. A bake could represent a region of interest in an image, a patient's medical record, or a collection of molecular features. MIL uses bake level labels, which can be either positive or negative. MIL algorithms are usually divided into two main parts, an instance level classifier and a bake level classifier. An instance level classifier provides information about the individual instances within each bake. The instance level classifiers help to access the features of instances within each bake, and their training results in differentiating between positive and negative instances without directly using bake level classification. Implementing instance level classification uses various algorithms such as SVM, logistic regression, or k-nearest neighbors. So, a bake level classifier is responsible for making predictions at the bake level based on the collective information of the instances. The output of bake level classifier is typically a probability or confidence score indicating the likelihood of a bake being positive or negative. MIL uses majority voting, average probability, max probability, and clustering techniques to achieve bake level classifications. Here you can see bake level classes. We have different instances, for example, instance 1, instance 2, and instance multiple instance. So here each instance here has a score, and based on those score it is classified into positive and negative bakes. And at then, by using some classifier, for example SVM, k-means, LR algorithms, we classify them into different bakes. So application of multiple instance learning in cancer diagnosis. A breast cancer diagnosis using MIL. Breast cancer diagnosis tasks include subtype classification, mammogram analysis, and lesion detection. Lung cancer diagnosis using MIL. MIL techniques have been applied to lung cancer diagnosis tasks, focusing on module detection and risk prediction. Prostate cancer diagnosis using MIL. MIL techniques have been employed in prostate cancer diagnosis, particularly in histopathology images, analysis, and detection in multi-parametric MRI. So these are different applications of MIL in cancer diagnosis. It can be used for bladder cancer, lymph node metastasis in various cancers, ovarian tumors, gastritis, colorectal cancer, and many others. So the advantage of MIL cancer diagnosis, reduce reliance on precise instance level labels, accommodation of inter-instance variability, robustness to noisy or mislabeled instances. Challenges associated with MIL: model interpretability, bake level feature representation. To overcome the limitations and improve the performance of MIL-based cancer diagnostic models, several strategies can be employed. Instance selection or weighting, selecting informative instances within bakes, or assigning instance weights can enhance the discrimination between positive and negative bakes. Ensembling and boosting. Ensembling multiple instance learning models or applying boosting techniques can enhance the overall performance and robustness of the model. So the prospects: integration of MIL with deep learning for enhanced cancer diagnostic accuracy, exploration of MIL in other cancer types, and clinical domains, incorporating domain knowledge and expert annotations into MIL frameworks. So, conclusion. The potential impact of MIL in improving cancer diagnosis and patient outcomes is substantial. By leveraging bake level levels and capturing complex patterns within bakes, MIL models can aid in early detection, accurate classification, risk prediction, and personalized treatment planning. Developing reliable MIL based diagnostic tools can enhance clinical decision making, reduce